Right, this question is pretty similar. There's a positive charge and a positive charge. Distance is 1.5 meters. Calculate the magnitude and the direction of the electric force acting between the two charges. So again, starting with my facts. So my R is 1.5 meters. My Q1, I'm just going to choose the first one. Now it's, what's N? Nano coulombs. I was having a blank. So if you use your blue equation sheet or have a Google, so if I can't remember, I'll just quickly go into Google. Nano units. So just Google that in and you can see that it's 10 to the negative 9. So that's how you figure it out. 10 to the negative 9 coulombs. So that is going to be left like that. My Q2 is 40 nanocoulombs. So that's the same as 40 times 10 to the power of negative 9 coulombs. Right, F is what I'm obviously trying to find. So let's write my equation down. There we go, and then just substitute those values in. 9 times 10 to the power of 9 is K. My Q1 is 25 times 10 to the power of negative 9. Other one is 40 times 10 to the power of negative 9. Divided by R squared, which is 1.5 squared. Alright, so let me just do that to make it obvious. So if I just chuck that in the calculator, I get 4 times 10 to the power of negative 6 newtons. Now to figure out the direction, you have to look at these two values. It's a positive and another positive. Two positives means that it's going to be repelling each other, so the force is repulsion. So that's how you figure out which direction it goes in. B. Draw vector arrows to represent the force acting on each of the charges. So that's pretty simple. It's a repulsion force, so is it going to go towards or away? Well, it's going to be a repulsion force, so it's going to go away, so like this. C. Use proportionality to determine the effect of the magnitude of the force acting between the two charges when the 25 nanocoulomb charge is replaced with a negative 75 nanocoulomb charge. Well, first of all, what I have to realize is I'm dealing with a charge. Charge, we use a symbol called Q. So I need to figure out if F is proportional to Q or inversely proportional to Q. Having a look at my equation, I'll just write it down over here again. Oh, that's not right. F, K, Q1, Q2, R2. To figure out if it's inversely proportional or directly proportional, all you have to do is figure out if they're in the same digit, same numerator, denominator, or if they're different. So if I explain that with highlighters, so basically F is in my numerator. Q, because that's what we're trying to see if it's proportional or not. Q, if I highlight one of them, they're both numerators. So this tells me that it's actually proportional. F is proportional to Q. So if F increases, Q increases as well. If F decreases, Q decreases as well. So using that, I need to figure out basically what factor the Q has been affected. So 25 to 75, ignoring the pluses and minuses for a second. What factor did it change? Well, it's a times 3 factor. Hopefully you understand that. So basically all that happens is Q got bigger 3 times. So to kind of act that out, you have to make sure you times the force by 3 as well. So my original force was 4 times 10 to the power of negative 6 newtons over here. So that was my original one. What would my 3F be? Well, it would just be 3 times that number. Right? So if I just chuck that in the calculator, that should be 12 times 10 to the power of negative 6 newtons. Now, this is where you have to be careful. When you're writing the direction, it's going to be affected because the sign changed from a plus to a minus. So have a think about it. I've got my negative and I've got my positive charge. Are they going to repel or attract? They attract, so this direction changes to an attraction. Alright, so that changes. Alright, let's have a look at II. The distance between the charges is halved. Now, how do we write something when something is halved? We write times a half. Right? We could write divide by 2, but that's the same as times a half. Now, if we've got to figure out again if F is proportional or inversely proportional to distance, so let me just write that again and we'll figure it out. Alright, so if you have a look, F is on my numerator, on my R squared. I can't just look at R because R is squared. R squared is on the denominator. They're the opposites of each other, so I have to make sure it's inversely proportional. That's very important. Now, all that happens is R is replaced by half R because it's getting halved. So my original R, if I write it again, if I write this equation again, is replaced by a half R, and then there's a squared. So if I kind of do that, let me just do that working out on the side. What is half R squared? Well, that is R squared divided by 4. Alright, so that's what it gets replaced by. So if I rewrite this F, proportionality, it's 1 divided by R squared over 4. Now you have to be careful what you do with this calculation. Obviously, you can't really chuck this in the calculator to figure it out because it's an R squared. So there's 2 ways of doing this. I'll write it maybe on the side. So one way, technically it's 1. Any whole number can be written into a fraction by dividing it by 1. There's a massive fraction. It's R squared over 4. So you can try, there's a little tip to it, kind of like, you know, when you times fractions or divide fractions and you do something called cross multiply, so things like that. There's like little tips to doing it. So all you have to do is times these inner ones together and it goes to the denominator, so R squared. And then you times the outer ones together and it becomes the numerator. So 1 times 4 is just 4. So that becomes the answer when you solve it. That's one way of doing it. Method 2. Now it's technically 1 divided by, because this fraction line over here, hopefully you can see which one I'm indicating. The big fraction line is basically divide sign. So I can write divide R squared over 4. Now, how can I also rewrite divide? Well, I can actually change it into a times and flip the fraction. That's just a rule that we learnt ages ago. Now, 1 times 4 is 4. Now, there's just 1 on the bottom. 1 times R squared is R squared. And hopefully you can see that they are the same answer. So I don't mind which method you use, but you do need to be able to figure it out. So if I write it again, my F is proportional to 4 over R squared. Have a look. What is it different? How is it different from the original equation? Well, hopefully you can see that this factor of 4 have disappeared, so it's kind of like a times 4. So I have to make sure I times 4 to the F as well. So it'll just be, let's have a look. I'll have to kind of move over here. 4. So my 4F is 4 times 10 to the negative 6, because that was my original 4. So that would be 16 times 10 to the power of negative 6 newtons. Now, the direction will be the same as the original, which was a repulsion, because, you know, the charge hasn't changed. It's still positive and a positive charge. Alright, let's try the last one. I. So what happens if this charge is replaced with a negative charge and the distance between the charges is half? So when all of these happen at the same time. So we know individually because it's done in I and II. So in I, right, we timesed 3 to the 4th. In II, we timesed 4 to the 4th. So if both of them happen at the same time, so my I would be times 3 times 4 to the 4th. So that is basically what would happen to the 4. So it's 12 times larger. So that's simply, what was my F? My F was 4 times 10 to the power of negative 6 newtons times a factor of 12. So that would be 48 times 10 to the power of negative 6 newtons. And look, again, the positive changed to a negative, so the direction changed. So it would be an attraction because we started off with a repulsion. I really want you to get your head around these and try it multiple times until you get it, because this is a really good example. And the thing is, proportionality, it is a bit of a hard concept, but you do need to understand it. So watch it multiple times until you get it. If you're really stuck, ask me questions in class. So make sure you do kind of get around to it though.